Welcome to Unit 2, Lesson 9, End Behavior Part 2. Let's describe the end behavior of polynomials. Okay, again, if we have x to an even power, both ends are going to wind up in the same spot. If we have x to an odd power, the ends are going to wind up in different spots. That's the whole point of this lesson and the previous lesson. The only thing we want to add on today is putting a negative out front. So watch the negatives out front. Okay, I explained the top half in the previous video, but now let's look at negative out front. So let's give you an example. So if we got f of x is negative x even 2, 4, 6, 8, 10, 12. As x goes negative infinity, f of x goes negative infinity. As x goes positive infinity, f of x goes negative infinity. So x evens will go to the same spot. So if I take f of x and I make it negative odd, as x goes to negative infinity, f of x goes to positive infinity. As f of x goes to positive infinity, f of x goes to negative infinity, which makes my x odd functions, x3 and higher, take the positive ones and flip them upside down. So how does this work? If negatives are, pay attention to your negatives as your leading terms, and what they do is flip the graph upside down. Okay, match each of the graphs to the polynomial it represents. So how do I know what I have here? If I distribute the x's, I get x times x, which is x squared. Then I had to distribute the x to the negative x. That makes negative x cubed. And negative x cubed goes with c. Okay, number 2 is x even. It's positive x even. Positive x even goes with a. And then if I do 5x minus 5x, I'm only worried about the x term. I'm not worried about the constant, equals 0. That gives me a constant. I should have probably changed the color. Sorry about that. Okay, a constant. Why'd I make it green like the other one? That wasn't too bright. Let's make this orange. Let's make number 3 orange. 3 is a constant. A constant polynomial makes a horizontal line. Now, let's look at D. D is any x odd. Positive x odd. I don't know what it is, but that's what D is. Okay, write an equation for a polynomial with the following. It has even degree. That means x is even. It has at least 2 terms. As the inputs gets larger in either negative or positive, the outputs gets larger negative. So we know there's negative x squared plus x. So it's going to look something like that. We don't know exactly what, but it's going to look something like that. It's even degree. Highest exponent is degree. It has 2 terms. And as the inputs get larger in either direction, the outputs gets larger in negative. So there you go. Looking at the next one, it has odd degree. So this is x odd, has at least 2 terms. As the inputs gets larger, negative. So x negative. Outputs gets larger, positive. As inputs gets larger, positive. Outputs gets larger, negative. That tells us this is negative x odd. So if I write negative x cubed plus x squared, it doesn't matter what any of the other terms are. The most important thing is the highest degree. Okay, let's look at example 3. M and N are each functions defined by this and that. Describe the end behavior. So all I need is the leading term. The leading term is negative x cubed. So that means it looks like that. Negative x odd, it starts high, goes low. So as x goes to positive infinity, f of x goes to negative infinity. As x goes to negative infinity, f of x goes to positive infinity. Okay, so n has a negative x even leading term. So if we were to draw this, it will look like that. So going down. So for the end behavior for n, I'm going to put this above in blue. As x goes to positive infinity, n of x goes to negative infinity. I'll draw 8, not a sideways 8. Negative infinity. As x goes to negative infinity, so that way, n goes that way. Goes to. The arrow means goes to. Negative infinity. Okay. All right, for number 2, x greater than 0. So we're going to the right. So m looks like this, and n looks like that for x greater than 0. Which has greater value? Now, when we're dealing with negatives, all of these are negatives. Greater values are closer to 0. So ironically, negative 9 is closer to 0 than negative 11. So whichever has smaller negative values is actually greater. And n of x, because it's x squared, has smaller overall x values, but it has smaller negative values. So that one works. So if we use to put numbers in, x cubed goes further away from 0 than x squared does.